All right, families of graphs. Look at the cute family. All right, so we're going to talk a little bit about what families of graphs really mean and the transformations. This is a review. You've done all of this before, but I want to make sure you understand what parent graphs you need to know and then what all the numbers that we put into the equations, what effect they have on the graph. So that's the big part of what we're going to talk about today. I'm going to ask you to pause the video at points so you can actually do sketches and make sure you're on track here. So why do I have pictures of my lovely family? Well, families of graphs have to do with the parent graphs, the original graphs that all of the other ones are based off of. So that's like Mr. Zabel and I. So we have these characteristics. Then kids. So we look at our children, they have characteristics that they share with us. There's things that they have in common. So that's very similar to what you see in families of graphs for equations. You have the parent graphs, the original functions, and then you have all of the different transformations that can occur, whether it's translating, dilating, we call it, where it stretches or compresses, reflections. Those are all ways that we can transform a graph. They're similar. They share characteristics with their parent graph, but they have their own unique look, which is very similar to kids with their parents. So it's a very similar idea. So I want you to take the parent graph sheet that has all the parent graphs. I need you to have graphed all of them ahead of time. So this is just more of a check that you know what those graphs look like, but we'll kind of talk through one at a time and pause the video as you need to make sure that you have the graphs in here. All right, so the first one's called the constant function. That's where the y value is always a constant, so it's a horizontal line. The next one is called the identity function because x and y is identical, y equals x. It's just a linear equation. So that's the parent graph that all of the other lines are based off of. If we change the numbers, we change the appearance of the graph. Okay, next three, we have quadratic, cubic, and quartic. Quadratic and quartic, very similar graphs, but the quartic is a little bit skinnier because when you raise something to the fourth power, much bigger number, but the same kind of beginning 3 points there. Both of those have y-axis symmetry. Cubic in the middle, that has origin symmetry. So that's our kind of our poster child for the odd function, whereas the quadratic x squared is kind of the poster child for even. So y-axis symmetry and origin symmetry. Okay, next three, the square root function. The reason there's only the top half of the graph, normally when you do square root, you have plus or minus, and then you would have the part on the bottom down here. The problem is if you have the part on the bottom, not a function, right? It wouldn't pass the vertical line test. So to make it a function, we only use the positive, and we look for those values like 1, 1, 4, 2, 3, 9. Use perfect squares. So much easier to graph. Okay, absolute value we recognize as the v. Those are two linear equations coming together. Greatest integer, that's our step function from before, where everything's rounding down. And then we have our last two, quintic, like quintuplets, lots of babies. That's to the fifth. And then the rational function, I underlined the part ratio. Excuse me. So rational function meaning ratio. So it's coming from the ratio of two things. It's just a fraction. That's why we call it a rational function. Both of those last two graphs have origin symmetry, although rational also has y equals x and y equals negative x. So those are our parent graphs. Now the other two pages that I want to talk about, just the practice graphs, are some of the ones that I had you do. Some of the graphs that I had you do before, and I want to talk about what each of the numbers do to affect those graphs. So looking at some of those. So before we check those graphs and see that they're okay, those different transformations, let's talk about what each of the numbers do in a situation for a parent graph. So we'll go through each of these, and I kind of color-coded them. So this is on the bottom of that parent graph sheet. So we'll just kind of go through the equation one thing at a time. If you have a negative sign out front, so look at the red one there. If you have a negative sign out front, what that does to your graph is it reflects it over the x-axis. So if the minus sign out front reflects over the x. That's a situation where the entire value of the function is changing. So it's going to flip it over the x. The next thing, that blue box that you see, that's the expanding and compressing, the steeper, wider. We call those dilations. That's the name of that kind of transformation. It's a dilation. So kind of like when you go to the eye doctor and you get your eyes dilated, if you ever had that happen, your pupils get really big, changes the size. So how do you know what it's doing? Well, if the number is bigger than 1, like if you times by 2 or 3 or 4, it expands it vertically. It makes the graph steeper. If you multiply by a number between 0 and 1, like 1/2 or 1/3, 1/4, that makes it wider. It's compressing it vertically. So it makes that wider graph. Okay, going inside. Okay, moving along. So inside, if you put a negative sign in front of the x, so look at the black thing there, that negative sign there. If you have a negative in front of the x is changing sign. What that will do is reflect over the y-axis. So it's a y-axis reflection, so just like our symmetry we talked about. And then, other thing inside there, the yellow box, if you have something in that yellow position in with the x, that is shifting your graph left or right. That's one of our translations that can happen. So if you see a minus, it means it's going to the right. I know that's confusing to people, but x minus 5 means the graph is going 5 to the right. If you see x plus 5, that comes from subtracting a negative. So if you see this, it's really coming from that, and that's a -5 shift. So what's ever coming after, it's how far has it been shifted from 0? Well, it's shifted -5 away. So you're looking at that distance from 0. Think of that as what you're doing on the inside there. On the outside then, the plus or minus, that green box, that's your up or down. So that's translating the graph up or down. So both of these together, those are called translations. So those are the translations when you translate from one place to another. And these last two are the reflections. So those are the transformations that can happen to a graph when we look at those different pieces. So here's what I need you to be able to do. Can you look at an equation and be able to tell what the transformations are? And then knowing what the parent graphs are, be able to sketch what that looks like. This would all be on the no calculator part of the test, being able to identify that. So I'm going to have you take a look at those graphs with the parent graphs here. And I think there are 7 of them all together. So I want you to graph it first and then take a look at the picture. So you're going to be pausing and doing that as you go. So when you take a look at the first 2, go ahead and pause, sketch them yourself, make sure you see what the different relationship is, and then check your answers with the video here. So please pause and do these, and then check your answers. So go ahead and take a peek at the solutions. Next one is reflected over the x-axis. Notice how the minus sign is right with the x, so it's reflecting over the x, and check your points. The next 2, we've got right 1. So that point of symmetry went to the right 1. And then from there, we're going up 1 over 1, and then left 1, down 1. Next one was left 2, up 3, so notice where that point of symmetry moved to. And again, left 1, down 1, and right 1, up 1. Okay, next parent graph. Again, keep pausing in between, sketch them yourself. We have an up 2. That plus 2 is outside of the radical, so we're moving that whole square root function up 2. So my vertex point, I always move that critical point first, either the vertex or the point of symmetry. It went up 2. From there, I went over 1, up 1, over 4, up 2, over 9, up 3. Using, again, those perfect square numbers makes it a lot easier. Letter B there, it's right 4. Look at the 4 inside with the x. That means it's going to the right. We see a minus there, so my vertex point would be at 4, 0, and then again, over 1, up 1, over 4, up 2. All right, last one of these. Look what happens. We have a left 3 and a down 1. So that vertex point goes to -3, -1. And then again from there, over 1, up 1, over 4, up 2, over 9, up 3. We get a really good look at what that graph is. All right, so just so you can practice a little bit on your own, what we're going to do is I'm going to have you complete this back side of your families of graphs sheet. I want you to try to see if you can figure out what each of those transformations were, and then what happens when you try to write the equations and make the sketches. So go ahead and pause the video. I'd like you to try these, and then I'm going to go ahead and put the answers up for you guys to check your work. So go ahead and pause and fill those in. And welcome back. And here is your solution. So go ahead and take a moment to check those through. Some things I want to point out, especially about the graphs. When you look down at the bottom here, this number 2, the vertex, or that point of symmetry, I should say, went down 2. So it's at 0, -2. To get the points on either side, this one has a vertical stretch of 2, which means when you go right 1, you go up 2 to 1, 0. And you go left 1, down 2 to -1, -4. That's the effect that 2 has on the graph. The steepness changes. It always works if you go left and right 1 unit to look at what that value is, because you're 1 unit from that vertex, but you can't continue that. You couldn't keep going over 1, up 2, because that would be linear. So just be careful when you're doing that as a sketch. Same thing in this next one. I went left and right 1 and up 1/2 from the vertex, because my vertical compression was a half. All right, so that's really our goal today, being able to look at different parent graphs, know what they are, and then be able to describe the transformations and make a sketch, and doing that all without your calculator, so knowing those graphs. So take some time, make sure you know what those parent graphs look like.